everyone. Welcome to Academy of Civil Services. Have you ever heard about the story of the formation of our universe? Yes, I'm talking about the Big Bang Theory, which happened 13.8 billion of years ago. But did you ever thought that would it be possible for the scientists to go back to the past and to give us results what was happening from that time? Yes, it's almost possible now. If you look at this image, you can see this is a galaxy, and the stars that you can see, they are 13.1 billion of years ago. That means it's creating a window, as if we are peeping through the window, through the holes to our past. Similarly, if you look at this image, you can see the formation as well as the death of a star. This is the Southern Ring Nebula. On the other hand, this is the Carina Nebula, which shows the formation of a star. I think as I was talking about nebula, you can understand what is nebula. It consists of dust, it consists of different gases that you will find during the formation of a star. So what do you think? How these wonderful results the scientists are giving to us? It's nothing but these are all the results of the James Webb Telescope that you must have heard multiple times. It's coming in the news, and therefore from exam perspective, this particular James Webb Telescope is very important. Talking a bit more about the James Webb Telescope, let me tell you, today we are getting this wonderful results out of this James Webb Telescope, and this is not an effort of 1 year or 2 years or 5 years. No, it's not like that. It's an effort of 25 years. Yes, it's an effort of 25 years where NASA, the scientists of NASA, the scientists of European Space Agency, and the scientists of Canadian Space Agency, they together created this big book, the James Webb Telescope, which today we call it as the strongest, the sharpest of all the telescopes. It took $10 billion for its creation or for its building, and thereby, of course, we can expect that amount, right? And thereby they are giving us such a wonderful result. Now, if we talk more about James Webb Telescope, we call it as the successor to Hubble's telescope, and you must have heard about that as well. But what makes James Webb different from the Hubble Space Telescope? The Hubble Space Telescope, it used the visible light. The visible light, you have seen it, the VIBGYOR, as well as the ultraviolet light. But on the other hand, if we talk about the James Webb Telescope, it utilizes the infrared radiations of the electromagnetic spectra. The infrared radiation is being emitted by those objects which generates heat. Now, as I'm saying that the objects that generate heat, that means you also generate heat, I also generate heat. Does it mean we also generate infrared radiation? Yes, you are correct. Every object that is having the capability to generate heat can radiate infrared radiations of the electromagnetic spectra. So we can consider this to be as a problem. Why are you being able to think? Because if you see the James Webb Telescope, which has been launched into the space, if it is getting the solar radiation continuously from the sunlight, obviously it will get heat, it will generate heat, and infrared radiations will be emitted from this particular telescope as well. This will create problem. This is the reason for which this telescope is kept almost near to the absolute zero. And when I say absolute zero, it's almost near to minus 273 degrees centigrade. Remember, the absolute zero. It has protective shield to protect itself from sun, from heating, plus it also orbits in the L2 point, which we call it as the Lagrangian point. You can see in the picture itself the Lagrangian point too. If any object is orbiting at the L2 point, it is getting a kind of barrier by the particular arc which will prohibit the sunlight to reach into it. This is what are the fascinating things about James Webb Telescope. More to come. We are expecting more results that James Webb Telescope will give us. Stay tuned for that. Thank you, everyone.